So, exam 2, free response number 1. Free response number 1 gives you a series and it says find convergence of the series if it exists. So, we have this very odd looking series where it expands out a bunch of terms and we end up with n factorial over 1 times 3 times 5 to the 2n minus 1. So, we need to go ahead and figure out if we can prove convergence or divergence of this series. Well, I do see an n factorial up there, so usually with n factorial, ratio test is a good place to start. So let's go ahead and apply ratio test and see what we get. So the formula for ratio test is L is equal to the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Okay, so a sub n would just be this series up here, and a sub n plus 1 would be n plus 1, which means that it's the next term in the series. So if I go ahead and write out what that is, as n approaches infinity, the limit, my a sub n plus 1 term would be n plus 1 factorial over, now on the bottom here I have a product of the sums, so I have 1 times 3 times 5 to the 2n minus 1. So the next term in the series would be 1 times 3 times 5, 2n minus 1, and then if I plug in n plus 1 into this term, I can get the next term. So if I do that, I end up with 2n plus 2 minus 1, so 2n plus 1 is the next term in that series. That's multiplied by, so I have to divide by a sub n, but I can always multiply by the reciprocal of a fraction. So because it's a fraction in this case, I'm going to go ahead and multiply by its reciprocal to make it a little easier. So I have 1 times 3 times 5 to the 2n minus 1 over n factorial. And then we'll close the absolute value bars around that. Okay, so we have our series now, so all we need to do is just prove whether or not it converges or diverges by simplifying. So I have an n plus 1 factorial and I have an n factorial down there. So what I'm going to do is I'm going to go ahead and expand this factorial out a little bit. N plus 1 times n factorial. My n factorials end up canceling. I'm just left with an n plus 1 up top. Now I have to go down to this series, so I have these two product of sums. So I can cancel out the 1s, even though they're just 1s, I'll go ahead and cancel them out. The 3s will cancel, the 5s will cancel, and I get all the way through the series, and every term in there will cancel up to the 2n minus 1. But the 2n plus 1 in this case will be left alone, nothing cancels with it. So now I've canceled about everything I can, so I'm going to go ahead and rewrite this. So L is equal to the limit as n approaches infinity of the absolute value of n plus 1 over 2n plus 1. Now if I take the limit of that as n approaches infinity, it's actually indeterminate because of infinity over infinity. So I'm going to go ahead and apply L'Hopital's rule to that, and I end up getting the limit as n approaches infinity of 1 over 2. Now applying the limit as n approaches infinity of 1 over 2 is just 1 over 2. 1 half is not dependent on n in any way, so therefore the final answer is just 1 half for that limit. Now, we are applying ratio tests, so we need to figure out if 1 half is going to cause it to absolutely converge, diverge, or inconclusive. So 1 half is in fact less than 1, so remember if it's less than 1, it's absolutely convergent. Now, if it had come out to 1 in this case, we'd have to actually apply a different test because it wants to know convergence or divergence entirely. So if this didn't work, we would have to actually try out another test and see if we could prove convergence or divergence another way. But in this case, it worked out, so absolutely convergent is what it comes out to be. So a final answer, if this was a free response, I would write by ratio test series is absolutely convergent. And that would be my final answer that I would box.
The Teaching Center, UF's Learning Resource Center.